Welcome to Cosmos in a Pod. We're doing the Space and Astronomy series, and tonight we're going deep, like really deep. We're diving into star clusters.
Oh, star clusters are great.
These aren't just, random stars, right? They're like cosmic fingerprints
Yeah.
showing us the universe's history.
Yeah, that's a really cool way to put it. It's like they're frozen moments in time, like little snapshots, and they give us clues about how galaxies formed, how stars evolve, all sorts of things.
So, okay, I'm hooked already.
Yeah.
Before we go too crazy,
Yeah.
what are star clusters exactly? What makes them so special?
Well, simply put, a star cluster is a group of stars, all hanging out together, bound by gravity, and they come from the same place, born from the same giant cloud of gas and dust. What's cool is they're like a controlled environment to study stars.
Oh, I see.
Yeah, it's different from those stars scattered all over the galaxy because stars in a cluster, they formed at about the same time, from the same stuff.
So it's like a cosmic lab where we can watch how stars, like different kinds of stars, evolve, right? Like all together.
Exactly. It's like a giant family reunion for stars. And like families, they come in different varieties. Open clusters and globular clusters. These are the two main types.
Now, I've heard those terms,
Ugh.
but what's the difference between them?
So open clusters, think of them as the younger crowd, still in the galactic disk where it's all happening. They're kind of loosely connected, few hundred, maybe a few thousand stars. And over time, they lose some members as stars drift away or the galaxy pulls them out.
So they're like the siblings that go off exploring on their own.
Perfect analogy. Now, globular clusters, they're the old-timers. They hang out in the galactic halo way out there. Think densely packed like a city of stars. Hundreds of thousands, even millions of stars. And their gravity strong, keeps them together for billions of years.
Whoa, millions of stars in one cluster. That's huge. But how do these clusters even form? What starts it all?
It all starts with giant molecular clouds. They're vast, cold, dark clouds of gas and dust stretching across light years.
Like the birthplace of stars, the nursery.
Exactly. But it needs a trigger to start the collapse, to get the star formation going.
So like a push to get things moving.
Right. It could be turbulence in the cloud, the shock wave from a supernova nearby, or even another galaxy pulling on it. These things make the cloud denser, hotter.
So it's not just random. There are forces at play.
Absolutely. And as the cloud collapses, it breaks into smaller pieces. Each one's going to be a star or a system of stars. Gravity is the big player now, pulls everything in, heats up the core, and eventually, boom, nuclear fusion starts, and a star is born.
It sounds chaotic, but also beautiful. And it doesn't just stop there, right? What happens after the stars are born in the cloud?
Well, the baby cluster is still inside what's left of that cloud. Young stars are powerful, they have stellar winds and radiation, and that blows away the gas and dust, like revealing the new stars.
So they're like emerging from a cocoon.
Yeah, you could say that. This is what we call gas expulsion, and it's a test for the cluster. If it's not big enough or the stars aren't close enough, this expulsion, it can overcome the gravity, and the cluster just dissolves.
So it's this battle between the winds and gravity, huh?
Exactly. And the winner decides if the cluster survives or not. And that's what leads us to the next really interesting part. How star clusters change over time. They're not just stuck the way they are.
Oh, so they're kind of like alive, changing and growing like us.
You caught it. Think about open clusters for a second. They're not as tightly packed. So they're stars, they can get pulled around by each other's gravity or by the galaxy itself. And after a while, some stars just kind of get kicked out. So the cluster shrinks over millions of years.
It's like a slow dance with gravity moving everything around.
Exactly. And sometimes a star gets flung out completely, becomes a field star all alone.
Wow, a lone wolf star. But what about those globular clusters, the packed ones? How do they change?
Globular clusters. They're tough because they're so dense. Gravity's got a tight grip. But even they change. Just takes much longer. One way is what we call core collapse.
Yeah, you mentioned that earlier. What happens there?
So over billions of years, right, all the stars in the globular cluster, they're pulling on each other. Some stars get more energy, move outwards. Others lose energy, sink towards the middle. And that makes the core, the center, more and more packed. That's core collapse.
Like squeezing it all inwards, getting denser and denser.
Right. The closer the stars get, the more they bump into each other, interact, and then all sorts of crazy things happen. You get binary stars forming, stars merging together, sometimes even stars getting shot out of the cluster at super speed.
So it's like this constant dance with gravity pulling and stars swirling around. It's amazing that they survive at all. But why are astronomers like obsessed with these clusters?
Because they're like natural labs, perfect for studying all kinds of things. We can learn about how stars evolve, how galaxies are formed, even how to measure distances across the universe.
Whoa, okay. That's a lot. Tell me more about how clusters help us understand all that.
Okay, let's start with stellar evolution. Remember how all the stars in a cluster are basically the same age, made from the same stuff? That means we can watch how stars of different sizes grow and change over time. It's like having a perfect experiment all laid out for us.
It's like a time lapse of a star's life, but with lots of stars at once.
Yeah, exactly. By looking at their brightness, their color, their temperature, we can piece together their whole life story and check if our theories about stars are right.
So what about galaxy formation? How do clusters fit into that?
Globular clusters, those old ones, they're like time capsules from the early universe. They tell us what conditions were like when galaxies were first forming.
Like fossils, but for stars.
Perfect. We look at their chemistry, their age, where they are, and it gives us clues about how galaxies built up their stars, how they grew, how they've changed over billions of years.
That's amazing. We can look back in time that far. But you also said something about measuring distances, right? Using clusters.
Right. Clusters, well, certain types of stars within clusters can act like cosmic yardsticks. We use them to figure out how far away other galaxies are.
Wait, how does that work? Stars as measuring tools.
It's pretty clever. There's a special kind of star called a Cepheid variable. It pulses, gets brighter and dimmer over time, very regularly. And the key is the time it takes to pulse tells us exactly how bright it actually is.
So we can tell how much light it's giving off, but how does that tell us the distance?
Well, think about it. Things that are farther away look dimmer, right? Like a light bulb across the room versus right next to you. So if we know how bright the star really is, and we see how bright it looks to us, we can calculate how far away it must be to appear that dim.
Wow, like a cosmic ruler.
That's it. And these Cepheids, they're bright enough to see in other galaxies. That's how we map out the whole universe.
This is blowing my mind. But even with all we know, I bet there are still mysteries about star clusters, right?
Oh, yeah, tons. The universe always has surprises. We've been studying clusters for ages, but we still don't have all the answers.
So spill the beans. What are some of the biggest puzzles that astronomers are still trying to crack?
All right. One big one is how the really massive star clusters form. We know the basics, but the details are fuzzy. Like, what exactly triggers those giant gas clouds to collapse and make so many stars at once? How do they get so packed together?
Yeah, it's like trying to put a giant puzzle together using all the clues we have.
Yeah.
So what else keeps you guys up at night?
Another biggie is how globular clusters, the old ones, stay together for so long. They're ancient, but they haven't fallen apart under their own gravity. It's a mystery.
Like they have a secret recipe for staying young even after billions of years.
You could say that. One idea is dark matter. You know, that mysterious stuff that makes up most of the universe's mass. Maybe it's helping to hold them together.
Dark matter, always making things more complicated. Any other ideas out there?
Well, some think it's all about how the stars move inside the cluster. As they interact, some get flung out, but it's like the cluster's adjusting itself, losing a bit of weight so it doesn't collapse.
So it's like a balancing act to stay stable.
Exactly. Maybe that's the key to their long lives.
It's incredible how much we can learn from these clusters, just groups of stars. They tell us about the whole universe.
And that's the beauty of it, right? The more we study the cosmos, the more we realize how much is still out there to discover. Every answer leads to more questions.
And we're just getting started. It feels like we've barely scratched the surface.
Oh, there's so much more to explore.
We're back on Cosmos in a Pod. And wow, what a journey it's been. Star clusters are incredible. So much more than just, pretty points of light.
Right, they're like keys to unlock the history of the universe,
Yeah.
How stars are born, how galaxies are formed, how to measure those crazy distances out there.
We talked about open clusters, those loose groups, and globular clusters, the ancient ones, packed with stars. And even those mysteries, like how the really big clusters form and how those globular ones stay together for so long.
Oh, and don't forget those Cepheid stars. Those are like our special tools to measure the universe, right?
Seriously, it's amazing how much we can learn from these, well, just groups of stars. But as we wrap up this deep dive, I got to ask, what's next? What are the hot topics in star cluster research these days?
Well, one that's really cool is what we call star cluster dynamics. It's basically looking at how the stars inside a cluster are moving, their dance, to figure out how the cluster's structured, how its mass is distributed, how gravity's playing its game.
So it's like choreographing a cosmic ballet with all those stars swirling around.
Yeah. And with the tech we have now, the telescopes and computers, we can make really detailed models. Like, we can simulate how a cluster changes over billions of years.
That's so cool. It's like having a time machine for star clusters. What else are you guys excited about?
Another thing is it's about those globular clusters again. Turns out they're even weirder than we thought. We used to think all the stars in one were like the same age. But now we're finding different groups of stars with different makeups and ages inside the same cluster.
So it's like finding hidden families within the cluster, different generations of stars.
Exactly. And that opens up a whole can of worms. Did these different groups form right there in the cluster? Or did they get captured from somewhere else? What does that tell us about the early universe, how galaxies were made? It's a whole new mystery.
I'm telling you, every time we think we know something, the universe throws us a curveball. It's amazing.
Right. That's what keeps it exciting. And the more we learn about star clusters, the more we learn about how our own galaxy, our whole universe, came to be.
I'm honestly just in awe of how much is out there and how much we're figuring out thanks to these incredible tools and these incredible scientists.
It's a privilege to be part of it, that's for sure. And who knows what we'll discover next.
I can't wait to find out. Thank you so much for joining us on this deep dive into the world of star clusters. It's been a blast.
My pleasure. Always happy to talk about stars.
And to our listeners, make sure you're subscribed to Cosmos in a Pod. We've got more space adventures coming your way. And don't forget to check out our YouTube channel, too. Until next time, keep looking up and keep exploring the universe.